basic introduction of digitalization of industrial processes, and then my colleagues will slowly get into decentralized manufacturing and small scale factories. So let's start with the basics of industrial revolutions. So in first industrial revolution, we were focusing on mechanical devices, for example, steam powered engines, and then electricity came, and then we had assembly lines and mass production. So the car manufacturing using assembly line by Ford was also part of this industrial revolution. And then we moved into third industrial revolution due to ICs, integrated circuits, PLCs, and computers. So we can think that digitalization actually started here. Factories were becoming more and more automated, and many processes have started to become automated in third industrial revolution. And then it started with networks, cyber physical systems, and Internet of Things. It's not only about people were connected, but devices have also started to become connected. So they were talking to each other, and it was very easy then to optimize process in automated manner. And now we are moving with Industry 5.0, and there we are talking about mass customization, cyber physical human intelligence, cognitive systems, and sustainability. So there is a very good report from European Commission. The reference is provided here. And based on that, I will do some introduction of Industry 5.0. It is focusing on human centricity. So humans should be in the center for development processes. So human-centric design and other processes during the development phase. We are going to build inclusive workforce and inclusive society. We should pay respect with each other towards our planet, towards our colleagues, or in our workforce. We are going to build flexible production processes. They are robust and adaptable. And due to certain scenarios, now we are also thinking about developing a product that is having value and supply chain very resilient. So we are not stuck at some point just by the supply chain disruptions. And finally, we are developing solutions. They are sustainable. So the things we are developing, they can be reused, repurposed, or recycled. And all these things can be done using digitalization. So the targets are the KPIs, key performance indicators we want to achieve, are better health and safety. Our process should be more energy efficient. Production quality should be better. Production yield should be better. We are going to innovate lots of products, and customization is also quite easy when we use digitalization in our processes. At the same time, we want to make sure that the harmful emissions are reduced. Downtimes in process industries are also reduced, and we are not creating waste in our processes. Coming to components that are required in digitalization efforts. So I will just see the pointer here. Here you can see the hardware options, and it's all about data. So we have to acquire data using sensors. We have to transmit data using our networks. Data storage takes place, and then the processing. So what we have seen in last few decades, that the development in all these areas have been really tremendous. Now IoT sensors are quite reliable, and the costs are going down. When it comes to network, the data transmission, now we started to talk about Gbps speed. Coming to data storage, now our data storage devices are having areal densities of data in terabit per inch square. Coming to processors, most of the people here in this webinar, I'm sure that they have their computers with processors, and the transistor counts are in several billions of transistors. And we have seen this huge development in last few decades. So when process industries are digitalizing their processes, usually they get all these components from specialized manufacturers, and then it starts to analyze their data to make their process more efficient. And here in this analysis part, we can think of from multivariate analysis to artificial intelligence, machine learning, deep learning, neural networks, all these. And analysis part is more depending on the industry we are working with. So it's more, we can say, local part. So they have their data and they have to analyze based on their own processes. But there are several challenges in this case also, because the kind of industries I will talk about in this session, they need sensors for harsh environment, because some of the industries, for example, like steel industry, aluminum industry, and such kind of process industries, they have high temperature environment. Sometimes they have very high magnetic field environment. So we have to develop sensors. They are fit to deal with those kind of environments. And also then we are lacking data from industries in two ways. Either they are not being recorded, or the industries are reluctant to share their data. And it's a big issue with many process industries. So we have to build some just kind of ecosystem where we can ensure and we can build trust on those companies that their data will be handled with anonymization, and there are standards in place. So for example, we have to make sure that the data privacy concerns will be solved for them. In next few slides, I will provide some introduction of the projects we are currently working with. And in these projects, we can categorize our industries into two categories. FMCG, fast moving consumer goods, for example, food, cosmetics, detergent, etc. These kind of industries, my colleague Chandana will talk about. And I will talk about these industries which we can call not so fast moving consumer goods. For example, cement, ceramics, chemicals, engineering, non-ferrous metals, minerals, steel, and water processing in a way. The first project I would like to introduce is Cognitwin. In this project, we have built an architecture of a toolbox, which can be used by various process industries to build cognitive digital twins for their processes. The project was funded by European Union in their H2020 project. We had 14 partners in the project. You can see a list of all the projects. It was led by SINTEF, and the project was finished last year. So when we developed this toolbox architecture, we have adopted a pilot-driven approach. So we had 6 industrial pilots in the project, and based on learning from these pilots, we have created the digital toolbox. In this project, we worked with 3 steel industries, 1 silicon industry, 1 aluminum industry, and 1 boiler manufacturer. So our approach was that we have worked with first principle and data-driven both models, because it is very difficult to rely on a single model when we deal with this not so fast-moving consumer good kind of industries. So we developed models from first principles and data-driven. We combined them to make hybrid models, and then we built interoperability between these two models. And finally, we introduced cognitive capabilities in our models. Finally, here you can see the Cognitwin digital twin pipeline. Our toolbox portal is available on GitHub, so you can go and have a look. So in this toolbox portal, we have made several components available for data acquisition, to digital twin representation, also for analytics, AI and machine learning, and finally for visualization as well. You can also go on the website of this project And that provides lots of research articles we have published during the project. So all the information will be available there. The next project is called Cogniman, and it started uh, just after Cognitwin, or almost in the end of Cognitwin. This project is coordinated by another Norwegian Research Institute, NORS, and here you can see list of all the partners. In this project, we are working with 4 industrial pilots. It is from glass fiber production to additive manufacturing, precision machining, and flexible manufacturing. The pilots, SINTEF is currently heavily involved is waste-free glass fiber production. So what happens in this case, I will just take one example here, that these glass fibers are quite thin, and during the production processes, they are breaking without any warning. So what we are doing here, by installing lots of sensors, measuring various parameters, and by doing data analytics, we are trying to find out the root cause of the failure and why the breakage is happening. So first thing is that. And in case, if it is not possible, we are also working towards making a model for prediction of breakage so that the uh, industrial pilots, they are ready for any unwanted situation. So by this way, we can reduce the downtime. And when these breakage happens in the companies, they also create lots of waste, because during that phase, this glass fibers are just wasted. So this is how we are dealing with this 3B pilot in Cogniman. And there are 3 other pilots. So you can also go on the website of this project and read about other pilots as well. So here is the architecture we plan to develop based on the learning from all these pilots. Since we are focusing more towards Industry 5.0, you can see we have a layer on social science and humanities and ethics as well here. Human-machine interface, also we are focusing quite much. We are also dealing with the pilots where human and robot can together work without creating any safety hazards. So that is also one of the focus here in this project. Finally, the last example I would like to provide, now we are moving towards small scale factories. This project is called Resource, the acronym, refractory sorting using revolutionizing classification equipment. So the background is that we use, for example, glass, steel, and cement, and we can see everywhere in our daily life. So these materials, they undergo high temperature processes. And during this high temperature processing, these industries are using refractory materials because they are they show quite good endurance towards high temperature environment. But these refractory materials, they also degrade with time and heat cycle. And in the end, they have to be recycled, or they should go to the landfill. So in this project, we are working towards a concept that how can we recycle this refractory material to use back in the refractories, or we can also try to find out several other downcycling or upcycling application so we can reduce the landfill from there, from refractories. Here you can see the list of all the partners, and this project is coordinated by RHI Magnesita in Austria. They are large refractory producers. So in this project, we are building 2 demonstrator units, and we can also call them as small scale factories, to make sure that the breakout materials, this refractory materials, in the end, it is available for other industries, other refractory industry to reuse. So these 2 demonstrator units are based on their size ranges. So for the large grain sizes, we are making this demonstrator A in 5 to 120 millimeters. And for the small scale grain sizes, less than 5 millimeter, we are making demonstrator B. So how digitalization is helping in this project? So what happens that the refractory material waste that is in the quantities of tons, and it is not very practical to characterize the whole material. So what we are doing here, we are using 3D imaging and hyperspectral imaging to get sensor data to train our AI-based models to find out the right spots to be characterized. And this elemental characterization is taking place through LIBS, a laser-induced breakdown spectroscopy, which is working on the spot-based analysis. So we have to find the right spot here to characterize. And this is how AI is helping us here. And finally, this AI-based real-time control is leading towards the final extraction process. So this is the end for my part. And then I would request Alex to take it further. Thank you. Yes, it works.
Okay. Thank you, Akhilesh. Welcome, everybody. I am Alex Butian. I'm the CEO of Wiz Research. And in continuation to Akhilesh's presentation, I'm going to share with you some of our insights about pairing human-centered digitalization with artificial intelligence. Okay. Now, the first thing I wanted to talk about is data sources. Everybody is talking about using artificial intelligence in many other ways, but the most important thing is to properly categorize the data sources. So I'm talking from an experience of integration in complex systems in the past 10 years. And different industry stakeholders, our partners or academia, they understand different things when we talk about the same data. And this is happening because each entity has a different interest in data. So if we look at the same data box, then we can understand different things. Now, data can be numbers, quantities, information, so on and so forth. But every time when we had difficulties in integration of our projects, we came back to the very basic question, like, what is data for you? What is data for me? What is data for our client? And if we are able to properly identify these kind of things, then the products and services we are trying to integrate in the complex systems became more understandable from a human perspective. Now, as soon as we can find out what is data for various stakeholders, then things are starting to get a bit more complex. So under this slide, I tried to present some of the most common data operations that we try to apply in the development project. So this is not just research, this is going towards commercial development projects. And I'm not going to try to take each one of those points, but I'm going to focus on some of them who are more relevant for our discussion for today. So as Akhilesh has said, everybody wants to use data, but collection of data has some perks. So it's up to a certain project and a certain use case to identify if they want high granularity data for collection or if they want some statistics data for collection. Because especially if we're talking about sensors, of course, the technical capabilities of sensors are somehow very high. So you can collect data from a sensor every millisecond, but is it worth it? Is it worth it for you or for a specific use case to occupy that much space or occupy the processing power regarding the sustainability of the energy sources to collect that much data? So before starting the actual process of data collection, there are certain questions that we usually ask and try to solve and get some answers. What is data collection for a certain use case? And regarding the future of digital service transformation, I would say, what is data collection for each one of the stakeholders? Because if in the initial stages of a production, you don't start collecting high granularity data, towards the end, even if you change your mind, there's not enough data. So the granularity cannot be expanded. Now, we've been witnessing some experience from previous project regarding the data storage, and this issue of data storage has already been solved in the past 20 years, but we are talking about enterprise applications, and everything that has happened inside an organization, it's already solved. Now the problem of storage gets to a new level. What happens if we try to make multi-organization data exchange? Where do we store the data? That would be the next challenge. Just a second. That would be the next challenge, like how we store the data if we try to collaborate with other organizations. And this is one of the most critical operations I've seen in the past 4 years. Now, skipping some of those things in the data operations, I would like to increase my attention to visualization. Now, it's probably impossible for human brain to understand or view all the data that's been collected. Now, in order to try to emphasize specific things that we are interested in the data visualization has to be less generic. So if we are talking about high level management, then they would need a godlike perspective over data visualization. If we are talking about small production units or something that we call department production units, they need higher granularity and less big perspective. Of course, there's also the maintenance part, which is kind of trivial at this point. And regarding the security aspects, I want to stop again on talking about migration. So everybody's planning for a future that means that the data would be staying in the same place, but this is not happening at all. Most organizations, most production units need to move their operations from one place to another, or if not move their operations, maybe borrow some of their data from one place to another. And this requires migration procedures. And migration procedures are somehow difficult because you don't know on which devices are you going to migrate. You don't know if the infrastructure that you're going to migrate, it's the same. And talking again about the access levels that are happening during the migration, because this is usually one of the points where data gets stolen. The most common point where data gets stolen is the migration operation. Moving forward to the right column, I'm going to pick from this column just two of them. So reporting. It can be, we can talk about internal reporting or same enterprise reporting, or we can talk about government level reporting, where different types of data and different types of data visualization and access has to be obtained in order to do the proper reporting. And when we do reporting, we definitely affect the data security, because we need to somehow understand or summarize some of the data points into something that can be less tracking, depending on the industrial secrets or other things that are involved in the process. Moving a bit down, I feel that in the past, at least in the past 9 months, there have been a huge progress towards data monetization. So we have worked with partners who have understood that their data is more valuable than the products they are selling and the services they are selling. So sometimes data is the service, data is the product. You don't need to focus that much on the process, or that has to be a a reliable a reliable source of income, but you have to consider more on the monetization policies and how the monetization can be, the strategy for monetization can be created by following all the previous operations that we've been discussing, because you want to sell the data, but you might not want to sell the knowledge that you have, or you might want to sell partially the insights of the data without sharing the raw data at all. So moving from the data operations to the next topic of my presentation. Akhilesh, can you move one slide? It's not working on.
No, I think it will be moved by keyboard.
Yeah, can you move one?
No, no, I cannot do. You can do by keyboard, not by. Okay. Okay, it worked.
Okay, thank you.
Mm-hmm.
So we're gonna talk now about twinning. So in various projects and especially in commercial things that are trying to advance faster than usual, people are talking about digital twins. And we've been doing up to this point, if I'm not mistaken, eight digital twins. And I would like to say that the word twin is actually kind of fake, because a twin, even in real life, means that there are some it might be some visual identity that looks kind of the same, but the insides are always different. So when in our projects we talk about digital twin, we like to follow a process called twinning. So even though in this diagram the two worlds, the physical environment in the left represented with white and the virtual environment in the right represented with gray, even though they are kind of mirrored, yeah, we can see that different things are applied. So if we look in the diagram and understand the physical processes that are happening in the physical environment, we can see that we can only measure them. So we cannot alter the reality. The reality can only be measured. While in the virtual environment, we update. Now, this is like an artist masterpiece. You can, of course, copy Mona Lisa if you want, but it wouldn't follow the same principles. You would probably have a micron difference, and because of the update from the left to right. And when we talk about manufacturing processes, the measurements are always based on stakeholders' interest. So one can measure a portion of the data, the other can measure another portion of the data. So having two different digital twins or three different digital twins that can represent different sides of the physical twin, that is always the case in the real world. So if we follow the process later on, then we kind of have to measure the virtual processes. So what could happen virtually with the rules that have already been identified. Now, if we talk about the measurements in the virtual world, of course, things are a million times more simple in measuring virtual sensors than measuring the real ones. Now, the problem with updating is while you measure the virtual ones, it's rather difficult to have or implement the same differences in the same time, talking about near real-time perspective, in the physical entity. So the several differences might appear. So on the outside of this diagram, we have the twinning process. That is some kind of a permanent process that's following up on these two worlds and trying to reproduce the changes from one to another. Of course, with a success rate that, from my experience, never goes above 80%. So you can try to achieve twinning up to a certain point. Okay, now back to human centricity, and the core thing of our discussion is what are the components of human centricity? So when somebody's talking about human centricity, what do they mean for manufacturing regarding the digital service transformation? So first is the demand for humans, from humans, sorry. So the demand has to come from humans. If the demand comes from processes, that's no longer human centricity. So we have to always remember this, like go back to the humans and ask them what do they want. And of course, we're talking about dedicated requirements per use case, precise limitations, and use case focus. Now, moving forward from the demand, we're gonna have to deal with the design for humans. Always we have to understand that the products and processes that are somehow operated in an industrial environment, they are made for humans. And even if sometimes we sacrifice the environment for this, we forget that the environment is the one who's sustaining the humans. So humans without environment, there's no such thing. That's why the ideation, the prototyping, the testing and validation has to be always kept in the loop with this metaphor in the mind. We design for humans if we want human centricity. Now, towards the end, this is a rather discussed hot topic nowadays, if we still have to keep the control from humans. And of course, we are biased. There are no robots in this conference as we talk right now. But we have to admit that as the systems are getting more complex, humans are getting more difficult times to control their systems, as we talk right now for one of the latest cars that were launched into the market. Now, most of the new cars that are being launched, whenever one of those cars are having a bigger malfunction, the insurance companies, they say, okay, let's replace the car, because the cost of humans to understand and fix an existing system becomes 2 or 3 times larger than producing a new product. And this is because we have traded control for humans towards control from machines. And we have started to slowly accept that we have some limitations, especially in terms of storage and calculations, that we have to delegate towards the machine. But we still have to keep decision support and analytics, automation and reliability of systems, and of course, we have to consider fallback and security. What happens if humans want or to take full control again? So all such systems, they need to be, when we talk about human centricity, we try to enforce in our discussions with our partners these 3 aspects. And again, since I like to talk about numbers, most of the times we fail in explaining our stakeholders that human centricity is not just demand for humans. We have to account all the others. Otherwise, it's partial human centricity that we are talking about. Good. Now, I have a slide that we've been polishing in the past years. It's called the intelligence cycle. And I would like to start on this slide from the human expertise point. It's intentional. There are no arrows in this diagram, so each one can go either way, depending on how our brains are mapped. But I'm going to go to the right. So I'm going to say human expertise has led us to data operations, because we have reached to a point where we can no longer process data with our brains, and we need operations and structure and so on and so forth. But as we previously discussed, do we care about the data quality, or we care about more about some bureaucratic processes, like we have data, yay, we're happy, but how qualitative is our data? Because everything follows this process. If our data doesn't have enough quality, then we're going to jump to automation, so on and so forth. So if we have a broken foundation, then of course the projects for digital transformation are going to suffer. Now, there's a debate here, which maybe some of the attendees would like to take later on in the questions about automation. Do we keep telling that automation is smart? Or we can say that automation is just some dumb rules that we have made, some limited set of rules that we can apply in certain situations. But of course, this is not intelligence. If the set of rules is limited, as it is right now in most of our industrial systems, we like to say about our systems that are intelligent, but in fact, they are just automated. Now, how do we move this from just automation to something that's smart? Of course, everybody talks about artificial intelligence and the fact that everybody has starting to use various artificial intelligence methods to create value. Now, the thing that I'm trying to say as a person who has been working with more than 30 different artificial intelligence projects, I would like to say that can we trust artificial intelligence for something related to the future? Of course, we can trust AI with something related to the past because we can feed AI quality data about the past. But can we trust it with something about the future where we cannot feed AI information about the future? Well, this is highly debatable. And if we talk about services, I mean, could we ask an AI what would the next users be looking for as a service where the next users haven't been even born? Would we expect to get a realistic answer, yes or no? I don't know that. But sometimes we also have to question these intelligent systems as I'm doing it right now. So how far are we going? And the last piece of this diagram is the value. Now, we keep talking about manufacturing and we talk about transformation from products to services, but an important question is how can we measure the final value? Are we looking at a comfort that's being delivered to a user right now and neglecting the environment? If yes, then that's a partial value. And most of the times this is a negative value. If we don't encounter sustainability, whatever process we are discussing is going to be ending up in a negative value. So talking about intelligence, I'm gonna shortly end up my part here. Talking about intelligence in the intelligence cycle is always open to debates.
Yeah, thank you so much, Alex. This is